Hi guys, it's Miss Simon. So I wanted to make this video today to help you guys out with science. So remember guys, we've been talking about non-contact forces. And remember, non-contact forces are when forces occur between objects that are not touching, okay? So for the past few days, we've been talking about the non-contact force of electric force, okay? Remember, electric force, you have a positive charge and you have a negative charge, okay? Positive and negative charges are always going to attract. Unlike charges always want to find each other. But like charges, like positive and negative, are always going to repel. They're going to push away from each other. Remember, the other thing that we learned about electric force and electric charges was that the negative charges are the only ones that transfer. We saw that when we rubbed the balloon on our hair and it pulled the negative charges off of our hair onto the balloon, and then that balloon became negatively charged and was looking for that positive wall. So that's why it ended up sticking to the wall. So today we are going to be talking about something called net charge. All right, we've calculated net force before. Today we're going to be talking about net charge. So go ahead in your notes, please. I'm going to share my screen. Remember, if I highlight it, make sure you put it down in your notes. All right, so net charge. Okay, how can you determine the electric charge of an item? Net charge is the total charge of an object, and it's determined by the number of protons and electrons in the object. So go ahead and put that down in our notes, please. Net charge is the total charge of an object, and it's determined by the number of protons and the number of electrons in an object. All right, so the protons are the positive charges, and our electrons are our negative charges. So when we look at net charge, it's determined by the number of protons that are in there and the number of electrons. So for example, guys, let me change this a little bit because I do need to change it. Let's say that you had an object that had 5 protons and 4 electrons. Okay, if you had an object that had 5 protons and 4 electrons, your charge is going to be positive because there's more protons than there is electrons. So let's kind of look at this a little bit deeper, okay? So let's think, how much more positive is that object? Well, if I have 5 protons, 5 positive, and 4 electrons, 4 negative, then my net charge is going to be positive 1. Why? Well, because I have 1 more proton than I do electrons. So my total net charge would be positive 1. So just like when we were finding net force, we subtracted to find our net force, we're going to subtract when we are finding net charge, okay? We're going to subtract our 2 numbers, and that's going to tell us what our net charge is going to be and whether it's going to be positive or negative. All right, so let's look at these examples, okay? I know it's a little bit hard to see, so I'll kind of outline them a little bit more. Okay, so for this example here, all right, you have 3 positives in the rock. We have 3 positives, and we have 3 negatives. So what would my net charge be? If I have 3 positives and I have 3 negatives, then my net charge is going to be 0, okay? Because I have the same amount of positives as I do negatives, and when I subtract those, I get 0. So the rock is actually going to have a neutral, a 0 charge. Now let's look at this balloon, okay? For this balloon, I have 1, 2, 3, 4, 5 negatives. So I have 1, 2, 3, 4, 5 negatives, and I have 1, 2 positives. So what is my net charge going to be if I have 5 negatives and 2 positives? Well, 5 minus 2 is 3, and I have more negatives than I have positives, so my net charge is going to be 3 negative. All right, let's look at this last one here. I have 4 positives. 1, 2, 3, 4, and I have 2 negatives. So what would my net charge be for this one? If you said 2 positive, you are correct, okay? Because I have 4 positive, I have 2 negative, so I subtract. 4 minus 2 is 2, and I have more positive than I have negative, so it's going to be 2 positive. All right, moving on. All right, so that's kind of what we just saw there, guys. Remember, so we take our number that we have the most of, whether they're positive and negative, we subtract them, and then that tells us what our net charge is going to be and whether it's going to be positive or negative. All right, so transfer of charges. Okay, so we did talk about already that the only charges that can transfer are the electrons, the negative charges. Okay, so go ahead and put this in our notes, please. Transfer of charges. So also electrical charges cannot be created or destroyed, but rather transferred from one object to another, okay? So electrical charge just doesn't come out of thin air, just doesn't come from anywhere, okay? It cannot be created or destroyed, only transferred. Now we saw this when we rubbed the balloon on our hair. It took those negative charges and transferred them to the balloon. So now, remember, objects always start with a neutral charge, a net charge of 0. So before we rubbed the balloon on the hair, this had a neutral charge. It had the same positives as it did negatives, and the balloon had a neutral charge, same positive as it did negatives. But then when I rubbed the balloon on the hair, it took 2 negative charges away and transferred them to the balloon. So now let's try and see if we can figure out what the net charge of the hair is now. So the net charge of our hair, I have, let's see, I have 4 positives now. And I only have 2 negatives because these ones were transferred. So if I have 4 positives and 2 negatives, what's my net charge of the hair going to be? Well, if you said 2 positive, you are correct because I have 4 positive minus 2. 4 minus 2 is 2, and I have more positive than I have negative, so it's going to be 2 positive. All right, moving on. So what is the net charge of an object with 8 positive charges and 5 negative charges? Is that going to be positive, negative, or neutral? I have 8 positive charges and 5 negative charges. So that one, if you said positive, you are correct. I have 8 positive. I have more positive than I have negative, so it's going to be positive. More specifically, we know that it's going to be 3 positive because 8 minus 5 is 3, and I have more positive than negative. Which of the following has a neutral net charge? So remember, neutral, it has the same number of positives as it does negative. Same number of positive as it does negative. Well, A has 3 positive and 2 negative. B has 1 positive and 4 negative. C has 2 positive and 2 negative. And D has 3 positive and 2 negative. So which of those has the same number of positive as negatives? If you said C, you are correct. C is going to have a neutral charge because it has 2 positives and 2 negatives. Which of the following statements below is true? Charges are transferred from smaller objects to larger objects. Electrical charges can be transferred from one object to another, but cannot be created or destroyed. Electrical charges can be created or destroyed. Electrical charges cannot be created, destroyed, and they cannot be transferred. Which of those is true? If you said B, you are correct. They can be transferred, they just cannot be created or destroyed. All right, guys, so tomorrow we will get into the types of force fields, okay? But remember for today, to calculate my net charge, we're just doing subtraction. We calculate the number of the most charges that we have minus our other, and that tells us whether it's going to be positive and negative. Hope this video was helpful, and I'll see you guys later. Bye.